guys. Today we're going to be looking not at a topic per se, but we're going to be looking at the application of geometric series in finance. Many of the students who are doing accounting, business, and actuarial science have done a bit of finance right now, and so they probably know what it's like. But we're going to use geometric series to apply ourselves to this one particular topic. So I think you remember the geometric series where we had, say, if we had a term A and we multiplied it to r to the power n, which would give us a r to the power 0 plus a r to the power 1 plus a r to the power 2 plus plus a r to the power n. Now, the whole idea is that a is our first term, right? And r is our common ratio, right? So the whole idea is that if we keep applying every single term to the common ratio, we know that the difference between this one and this one is r. So we keep multiplying r to the next r, so it just keeps changing. The power to r keeps changing until to the power n. Now we are going to apply the same fundamental to finance. Let's look at this for example. If we want to have a loan, say to the amount, or let's say we want to make, let's leave a loan aside, let's say we want to make an investment. Now, in this investment, we want to know how much we shall have in n years, right? In n years, sorry. Let's say we want to know how much we shall have in n years after we have invested, say, an amount, this is n years, we have invested a certain amount in, let's say, amount A, just like here. So we know that the interest rate is equals to I, right? We can use, if we move to this side, we can start to use geometric series in this way. We know that if we invest amount A, after 1 year, we shall have 1 plus I to the power 1, right? And if we, after 2 years, we shall have 1 plus I to the power 2 by the principle of compounding. After 3 years, we shall have 1 plus I to the power n, so to the power 3. And if we continue until the nth year, we shall have a into 1 plus I to the power n. As you will see, there is a common multiple here, and this common multiple, the common ratio here is 1 plus I. So we shall know that the sum of this 1 plus I to the power n is equals to, if you remember the formula for a sum of a series, it's 1 into 1 plus 1 plus I to the power n all over 1 plus I. This is the sum of a formula. This is how we can get how much money we shall have at the end of the investment. Now, it's a very interesting principle, and we can also use it to find out if, let's say, we want to put money aside every single year, and we want to know how much we shall have at the end of a certain amount of year, at a certain amount at a certain period. That one will be so simple because we'll just use the reverse of this formula. Now, let's say we use this multiple, which is equals to 1 plus I. We have gotten the inverse, or we've got the inverse of this function to get 1 over 1 plus I. So in this case, we shall have the summation of a v to the power n, yeah, will equals to a v plus a v to the power 2 plus a v to the power 3 plus plus a v to the power n. That way we can find out. Now what we have been doing in the previous process was a compounding. Now we want to do a sort of discounting. So in this case, we shall have a formula which is equals to 1 into v to the power n over 1 minus v. These two formulas are very fundamental formulas in finance when they come to calculating loans, when they come to calculating how much they should give people and how much people can pay back. And even as for personal finances, you can see how much you're going to invest with time. Those who are studying actuarial science, I did find out that these particular formulas, like this one, in the Society of Actuaries, is represented as this. And this other formula is represented as Vx. I hope this will be very useful, as we shall finally get to know how we can apply many of the concepts that we learn every day in school. Thank you very much.